Today, we're going to pull back the curtain on one of the hidden engines of our world. It's a simple, spinning piece of metal that's probably responsible for making the very clothes on your back. It's called a tappet, and it's the absolute key to a process called tappet shedding.
But first, just take a second. Look down at what you're wearing. The fabric of your shirt, maybe your jeans, the chair you're sitting on. Have you ever really thought about the incredible, high-speed mechanical process that wove all of that together?
Well, for a huge amount of that fabric, the whole story starts right here, with this. A surprisingly simple, kinda oddly shaped, rotating disc. Now, it might not look like much, but this thing is a little marvel of engineering, and it's designed to solve one single, fundamental problem in weaving.
Okay, so let's dive into that. To really get it, we first have to understand what that core challenge actually is. What is the fundamental problem that all weaving has to solve? You know, at its heart, weaving is all about interlacing threads. You've got a set of lengthwise threads, they're called the warp, all lined up and ready to go. Now, to make fabric, you have to separate them, lifting some up, pushing others down, to create a clean path for the crosswise thread, the weft, to shoot through.
And that temporary V-shaped opening that you create, it actually has a name. It's called the shed. Creating this shed cleanly, quickly, and reliably, maybe thousands of times a minute, well, that's the whole ballgame. So how on earth do you do it?
And that is what brings us to the ingenious mechanical solution that became the true workhorse of the textile industry, the tappet.
So what exactly is a tappet? Well, just think of it as a really specialized cam. Its entire job, its whole reason for being, is to take simple spinning, just rotary motion, and turn it into a perfectly timed up and down movement. And that precise movement is what makes the shed. Now, not all tappets work in exactly the same way. With positive shedding, the mechanism is in total control. It physically pushes the threads up, and it physically pulls them back down. But with negative shedding, the mechanism only does the heavy lifting part. It relies on something else, like springs or even gravity, to get the threads back to where they started. So the big difference is really about the level of control. All right, now for the fun part. Let's see exactly how this thing works. It really is like watching a mechanical ballet, where every single movement is perfectly, and I mean perfectly, coordinated.
Okay, so if you look at the mechanism, everything kicks off right down here at the bottom. See these kind of weird-looking discs spinning on the shaft? Those are our tappets. They are the absolute heart of this whole operation. And here's where the genius comes in. The shape of the tappet is the programming. As it rotates, its carefully designed curves and edges push against these levers. And just like that, it transforms that simple spinning into a super precise up and down rocking motion.
That rocking motion is the final step. It gets transferred all the way up to the harness. That's the frame holding all the threads. As the levers move the harness, it pulls some threads up and lets others fall. And boom, there's your shed. A perfect path is created. But none of this is happening by chance. This entire mechanical dance is choreographed down to the millisecond, all perfectly timed to the loom's 360-degree rotation. It's a symphony of moving parts, and the tappet is the conductor. So let's break that rotation down. At 0 degrees, everything's flat, the threads are level. By the time we hit 120 degrees, the shed is completely open. At 150 degrees, the shuttle with the weft thread starts flying across. The shed stays wide open until 240 degrees, and then it starts to close, locking that new thread right into place. It's a perfect, repeatable cycle, over and over again. So this system is clearly brilliant. But like any good engineering solution, it's all about trade-offs. You gain something, you lose something else. So let's take a quick look at the good and the bad of this whole approach.
The advantages are huge, which is why this system is so common. First off, it's the simplest and cheapest way to do this. It can run at incredible speeds, and it does it while using less power. And here's the kicker. It actually makes fewer mistakes in the fabric than more complicated systems. It's a true industrial workhorse.
But yeah, it's not perfect. All that high-speed movement can put a ton of strain on the threads, sometimes causing them to break. A poorly designed tappet can create a jerky, inefficient motion. And probably its biggest limitation, you're not going to be weaving super complex patterns. This system is built for speed and simplicity, not for fancy, intricate designs.
So when you put all of the pieces together, you really start to see why the tappet is an unsung hero of manufacturing. Let's just wrap up with why this simple little device matters so much.
This quote from our source really gets to the core of the tappet's genius. The movement isn't just a clumsy up and down, it's variable. The shape is engineered so that it moves the threads slowly at first, so they don't snap.
then fastest in the middle when the path is clear, and then it slows down again before it closes. It is an incredibly smart, incredibly elegant design.
And the precision needed for this to work is just mind-boggling. For the whole system to sync up, the main crankshaft of the loom has to rotate at exactly, and I mean exactly, twice the speed of the bottom shaft that's holding the tappets. That 2-to-1 ratio isn't a suggestion. It's the absolute, non-negotiable heartbeat of the machine.
So here's the bottom line. This simple, reliable, and amazingly efficient mechanism is the hidden engine that weaves the fabrics all around us, every single day. From the t-shirt you pulled on this morning to the upholstery in your car, there's a very good chance a tappet was the thing that made it all happen. So there you have it, a simple, rotating shape that literally weaves the fabric of our world. And it kind of makes you wonder, doesn't it? What other elegant, simple mechanical solutions are out there, hiding in plain sight, just silently shaping our daily lives?